Hi, this is Sayantani. Welcome to my class. Welcome to another video of this class. In this video, we will discuss about structure of the earth. This is your class 9 geography chapter 3. And from this chapter, we will study inside the earth, the layer of the earth and the major domain of our earth. Okay. So without any further delay, let's get started. First, what are the age of our planet earth? We know that the earth is the third planet in our solar system, and earth is either you can say 5 billion years or 5,000 million years old, but still it is process of changing. It is changing day by day. Still this process is going on. Okay, and the radius of the earth is 6,371 kilometer. This is the radius of our earth. What are the three major domain of our earth? That is your lithosphere, hydrosphere and atmosphere. Lithos means rocks. It is consist of or made of rock. Hydro means water, so it is made of water. And atmosphere means related to your air. And intersection among the hydrosphere, atmosphere and lithosphere, it's form the biosphere. All living organisms live here. We will discuss what are the sources of interior of the earth and how could you know about the inside of our earth. What are the material it is consist of, what type of rocks is there, what minerals are there, how much temperature is there. We should know about that, and we know that the radius of our earth, that is 6,371 kilometer. The source which provide knowledge about the interior of our earth may be classified into three groups. We can classify it into three groups. One is your artificial sources, another is your natural sources, and the evidences from the origin of the earth. First, artificial sources. Artificial sources is, what are the artificial sources? That is your temperature, density and pressure. Okay, these are the we can also call it the indirect sources. We cannot go inside our earth, right? But we can get to know the details about the inside of our earth from the temperature, density and pressure. Some scientists start digging the earth's surface and they can reach only 8 to 10 kilometer, and when they start digging, that time when they move downward, the temperature started increases. Okay, from that sources we can assume or we can estimate it that the temperature of our center of our earth is very high. Okay, next one is your pressure. When they dig the land surface or earth surface, that time they get to know that the pressure of our earth surface is very high, and the material that existed in the center of our earth they are very densely in state or densely in nature. So these are the artificial or indirect sources. What are the natural sources? Natural sources, two type of natural sources we can consider, or it can also consider as direct sources, because when the magma move upward and spread over the earth's surface and become lava, after solidification of lava, we can identify the what type of materials are there in lava. Okay, and from that we can get to know that what type of minerals are there inside of our earth. Next natural source is your earthquake. Okay, due to the earthquake, the landslide occur. When the landslide occur, or due to the earthquake, fractures we can be seen the fractures. So due to that, we can identify the rocks type and the minerals that made of that particular rock, and the type of minerals we can assume that type of minerals and that kind of minerals are exist in the inside of our earth. The evidence is the origin of the earth, that is the planetesimal hypothesis. From that we get to know about the inside of our earth. This is the layer of our earth. We can compare it with the boiled egg. We all we all know what is boiled egg. In your boiled egg, there is a hard layer, then the white part, and yellow part is your in the center. Okay, in the same way, we have in our earth, we have our earth is that is your the hard layer, that is crust, then the mantle, and this center of our earth is your core. Okay, the three layer of our earth is crust, mantle, and core. Okay, we can also compare the layer of our earth is with the watermelon. Okay, the green part is compared with crust, the whitish part is mantle, and the red part is your core. So one by one we will discuss earth, crust, mantle, and core. What is crust? We compare crust with the white shell of the boiled egg, right? It is the outermost layer and it is a solid layer. In the same way, crust is the outermost solid layer. And the word lithosphere is derived from Latin word lithos. And what is the meaning of lithos? That is your rock. And we can also call the crust as a rock sphere or lithosphere. What are the features? See, this is the outermost layer, number one. What are the elements are made of the crust? That is your silica, magnesium, and aluminum. Okay. One more thing, the minerals we can find in the inside of our earth. We can arrange it from lightest to heaviest. Okay, and the lightest minerals found in the upper part of the upper part or outermost part. The most lightest minerals is your silica, aluminum, magnesium, and the heaviest or heavier minerals that are nickel and ferrous that are found in the center of our earth. Okay, the mineral that consists of the crust is your silica, aluminum, and magnesium. Okay, and the crust is extended up to 60 kilometer. Somewhere in case of continental crust, because our crust is divided into two parts: continental crust and oceanic crust. Continental crust is made of the silica and aluminum, and oceanic crust is made of the silica and magnesium. Oceanic crust related to your oceans and continental crust related to your rocks. Okay, and in continental crust it extended up to 60, somewhere it is 40 to 60 kilometer. In oceanic crust it is up to 8 to 10 kilometer. In next slide we will study details about CL and CIMA. And the temperature we can find it in the crust is 600 degrees Celsius, and the density is varies to CL and CIMA or continental crust and oceanic crust, that is your 2.7 gram per semi-cube or semi-cube to 3 gram per semi-cube. Okay, this is a picture of your CL and CIMA. And next slide we will discuss the classification of the earth crust. As I told you that the crust is divided into two parts, CL and CIMA. And CL is the topmost layer. CL is called the continental crust. CIMA is called oceanic crust. And we will discuss in last the discontinuity, and the location of the crust CL is above the Conard discontinuity, and CIMA is between Conard and Moho discontinuity. What are the elements that form CL and CIMA? CL, SiAl, silica and aluminum, and CIMA, silica and magnesium. And the density of the CL is your 2.7 to 2.85 gram per semi-cube, and CIMA is 2.85 to 3 gram per semi-cube. And the type of rock that found in the CL is your granite rock, and basaltic rock found in your CIMA. And as I told you that the CL is extended up to 40 to 60 kilometer, and the CIMA is extended up to 8 kilometer. And the earthquake waves or seismic waves moves there. Only P wave can move in crust. The P wave, the speed of the P wave can be recorded the 6.1 km per second. In case of CIMA, the P wave can move the 6.9 km per second. Okay. Next is your asthenosphere. Asthenosphere, it is the semi-liquid zone between crust and mantle. Below the crust and above the mantle, there is a semi-liquid zone. This is called asthenosphere. It is up to 350 km, and the velocity of the earthquake decreases in it. Hence, it is referred to as low velocity zone. Why asthenosphere is called a low velocity zone? Because the velocity of earthquake decreases in it. The velocity of the P wave in CL is 6.1 and SEMA is 6.9 respectively, that I told you in the previous slide. But that wave decreases in asthenosphere. That's why it is called the lower velocity zone. P wave and S wave can move in it. Due to the temperature pressure inside the Earth's surface, the rock like the peridotite melted in this layer. That rock type, the peridotite, melted in this asthenosphere, and all the plates are moves in this asthenosphere. Okay. Next layer is your mantle. Another name of mantle is your mesosphere. The boundary between crust and mantle, it is called monophysitic continuity. What is discontinuity? It is the transition zone. Okay. And the element, that is, this is your mantle. And if we consider it, the crust to core 100%, we consider it as 100%. Only 1% can find in crust. 84% you can find the mantle, and only 15% is covered by core. Okay, 1 plus 84 plus 15%. The crust, the major portion of the inside of our earth is covered by mantle. What the element we can find in the crust? That the chromium, ferrous, silica and magnesium. That's why this layer is called chrophesima. Chrophesima. Chromium, ferrous, silica and magnesium. Okay, chrophesima. And the temperature is, as I told you earlier, that when the scientists are digging the earth's surface, when they move downward, the temperature start increasing. So the temperature we find in crust is 600 degrees Celsius. So it is mantle. So you already this layer extended up to 2,900 kilometer. So the temperature automatically increased. The temperature of this layer is 2000 to 3000 degrees Celsius, and the density also will be high, 3.4 to 5.5 gram per semi-cube. And this layer is also classified between the two, upper mantle and lower mantle. This layer is also divided into two parts, upper mantle and lower mantle. Next one is your core, or another name of core is barysphere. The zone which extended up to the center of the earth is called core. Okay, core. The density here, density will be high. So the density is 9.2 to 13.3 gram per semi-cube. It extended up to 6,371, but this layer is also divided into two parts, upper core and lower core. In upper core, it is 2,900 kilometer to 5,150 kilometer, and the lower core is extended in 5,150 to 6,371 kilometer, and the temperature is 6,000 degree here, and the volume of this layer is 16%. The mass consists of here is 32%, and the pressure of the center of the earth is 3,500 kilobar. Pressure we measured it as kilobar. The heaviest minerals are found in this layer, and the nickel, iron are found, but they are all molten in stage. Why they are in molten in stage? Because of the high temperature. Due to the high temperature, the nickel and iron are molten in stage, and due to the high temperature, the liquid iron generates its own electricity, and so under pressure, the core is source of the earth magnetic field. our earth has magnetic field due to the liquid iron generates its own electricity, and because of the high pressure create the earth's magnetic field. And the wave speed, the the velocity of the seismic earthquake waves is 11.23 kilometer per second. Now, what is discontinuity? Discontinuity is a transition zone in which the earthquake waves changes its position beneath the earth's surface. It is called your discontinuity. Okay. There are 5 discontinuity identified by geology. One is Conrad, another is your Moho, Repetti, Gutenberg, and Lehman. The Conrad discontinuity is found between upper crust or lower crust, means CL and Sima. Between CL and Sima, we can find the Conrad discontinuity. Next, between the crust and mantle, we can find the Moho discontinuity. And between upper core, upper mantle and lower mantle, we can find it the Repetti discontinuity. And Gutenberg discontinuity discontinuity finds in between the mantle and core, and between upper core and lower core we can find Lehman discontinuity. Okay, this is all about the chapter. I hope you understood that. If you understood that, if you like this video, please press the like button and subscribe my channel and share with your friend. And next video will be uploaded very soon. Thank you.